Hello and welcome back to hashtag WTF is SRE. Are you sharing? Are you learning? Are you sharing about your learning? Please do. And please be an active participant. You can make comments, continue the discussion, ask questions to make my job easier. These are all very important. The next topic is an interesting one for me because when you think SRE, you think, well, yeah, obviously security has to be involved in site reliability. It's the biggest risk to reliability if you think about it in a way. But then you think about how insanely difficult the job of a site reliability engineer is already to then be in charge of security. So I'm very excited to bring Anaïs to the stage, come on board and teach us everything cloud native, and which again, cloud native often creates more insecurity. So I'm excited to hear more. Thank you so much.
Thank you. Awesome. I'm excited. Welcome, everybody, to my talk on providing cloud-native security equipment to extinguish the fire. I hope you're enjoying the conference so far, and yet you will enjoy my talk. My name is Anaïs Urlichs. The talk is going to be long, so if you have any questions, comment in the chat, and I will answer them later in the chat, or tweet at me at Urlichs. So who am I? Why do I want to talk to you about cloud-native and security? Well, it's a bit of a longer story, which I will cover everything within this presentation as well. So I feel like it's important to elaborate of where I'm coming from and what I've been doing in the past year and why I want to talk about this topic specifically. So I started my career in the blockchain space, working as developer advocate for open source blockchain projects. Then something happened, which I'm going to talk about in a second, which caused me to look at different industries. And that's how I stumbled into cloud native, into the DevOps space, and worked first as developer advocate and then tried myself as SRE last year. Now I'm back at developer advocacy, working at Aqua Security as their open source developer advocate. Now, what's the fun story that happened? So while I was working at a blockchain startup, and don't worry, this talk is not about blockchain or tokens or related, but I was working at a startup and we were mainly focused on onboarding engineers to our project to contribute to our open source project. However, similar to other blockchain crypto startups, at some point we wanted to provide a token to our community. And this token is basically a promise that in the future, people can access the utility of the project. So we had this token sale with a third-party platform, and we expected a few hundred people maybe to want to access our tokens. It ended up being several thousand people who wanted to access the platform at the same time to access some of those tokens, which we didn't expect. It was a huge disaster with lots of unhappy community members. I was at the time managing the Discord channel, and that was my experience, my first experience realizing how important SRE work is, and yeah, providing a great user experience to your customers, to the people who want to access your project. Now, I've wanted to provide like some fun memes or something, but related to that topic, I couldn't find much. Now, in this talk, I'm not going to talk further about blockchain. I just want to share this experience since this is a SRE-related conference, and also because within the crypto space, you have to put a lot of focus on security of the protocols of those peer-to-peer architectures, right? And from there, I moved then into the cloud-native space. Yeah. So what is this talk actually going to be about? Right? Why does the story matter, and so on? First of all, I want to talk about finding the fire, finding fires in your platform, in your infrastructure that you might not know are there yet, or that you might have difficulty at the moment to discover, or that might come up in the future as your platform scales and advances over time. Then I'm going to talk about how to extinguish the fire once you found it, and thirdly, making sure that it doesn't start again over time. Now, where's the fire? What is the fire that I'm actually talking about? When I was working as SRE last year, we had two main types of tools that we were using. Some tools to observe the fires that were within our platform, and some of them to manage the fire in a way. And some of them are listed here. So we used, for example, we used Grafana to have pretty dashboards, to have pretty insights of what's happening within our platform, within our infrastructure. We used Prometheus to collect our metrics. We had Grafana Loki running with promtail to access logs. We used Jaeger, we used Thanos at some point. So a bunch of pretty observability tools. All of them are great. And then also we used Helm pretty extensively in Terraform. However, throughout this entire time, we never really focused on security tools. And I never really focused on security tools within my SRE work. The first interaction that I really had with security tools was when I was joining Acro Security in their open source team. However, a lot of the incidents, like Jen mentioned earlier, that we experience as SREs are actually related to security. And the main one that I want to focus on within this slide are misconfigurations. The cloud native space is very, very complex, and we use lots of different complex tools that we have to configure, lots of YAML files that we have to configure correctly to set up our application or set up related tools to monitor our application, right? So the number one security vulnerability that a lot of companies report are actually misconfigurations. Now, the YAML manifest itself, they are usually checked for just if they are valid upon installation. However, misconfigurations also relate to is your container using the latest image, which you might not want to do, and other security-related issues and configurations. So within all of those tools, I didn't have the experience using security-related tools, and I never really thought about it until I was joining Aqua. However, and this is kind of the premise of this talk, I want to make the point that SRE-related goals are security goals, and vice versa, that we can actually integrate security goals easily within our existing SRE tech stack, let's say. Also, I want to add that a lot of times when we're talking to engineers about SRE, they mark that their ideal of an SRE, or also within the SRE culture, it's quite common that SREs sit within the engineering teams, right? That they provide the specific tooling for their part of the application that enhance observability. And allows all the fancy SRE stuff. However, we don't talk as much about security being a component of our development lifecycle, let's say, but it should be. And I want to kind of show you in this presentation that it's actually, it's not that difficult to get started with it. So overall, I want to show you that from moving from DevOps practices to cloud native practices and SRE practices, that we can also implement security practices. So while SRE practices implement a lot normal DevOps practices and cloud native practices, they are all overlapping. We can also include into the mix security related practices and goals. So when we're talking about scalability and we want to make sure that our application is in a state where it can scale over time as our demand increases, as in our user base increases, we want to make sure that while our application scales, it doesn't become less secure. Similarly, we want to have visibility into for example, the error rate of our application. We also want to have maybe visibility into the vulnerabilities, the number of vulnerabilities that our application has within, or that new deployments have that are running within our cluster. Then we want to reduce, while we also add new components, new tools to the mix that we are using, we want to reduce the noise, the toil that we actually have to manage alongside, right? It's always great to show in little demos those fancy new cloud native tools, but they actually have to fulfill a purpose, right? We don't just want to add new tools over time and then have to manage them and they don't actually have a clear purpose or clear use for us, right? So we want to have easy access information that matter to us, and ideally in an automated way, so that we don't have to manually check our cluster, for example, for vulnerabilities or for other security issues. And alongside it, another big component is creating ownership and clear communication with engineers, because there's a lot that we can do as SREs to enhance, to provide security-related education within teams and support engineers in accessing cloud native related security tools as well. So going beyond the practices, again, to iterate on it, I basically want to show you that you can combine security practices with SRE practices. There is a lot we can take from SRE tools to enhance and implement our security-related tools. So while we define what a healthy service looks like, we also have to define what a secure service looks like. So basically, I make the assumption that a healthy service is also a secure service. That should matter to your user and it should matter to you. Now, how can we do that? And I know I'm running like really quickly through these slides because I have a demo at the end that I want to have enough time for and then for your questions. So there are lots of different practices that we can also take from the SAE world or that we can kind of build upon to provide further security practices. So for example, when we're already investing into runbooks and documentation, what happens in certain incidents? What do you do? Whom do you call? What is the process that you have to follow? We can add to that the security-related incidents, right? Then within your delivery pipeline, you can add already security vulnerability scanners that, for example, prevent, that check new deployments before they are being deployed in your production environment or in your staging environment. Defining ownership is great also for security. Then setting explicit expectations on people on what is their job like related to security, what ownership are they supposed to take in that process, active communication like mentioned earlier, and so on. So these are just things that we can build upon when we want to encourage our security first culture, let's say. So just this slide is a bit useless. It's basically combining both practices, tools, and culture to implement security-related tools. So the SRE tools that I talked about at the beginning, right? These are the tools that I talked about at the beginning. And when I joined Aqua, I was thinking, oh, where were the security tools that we weren't using? Where were they, right? So this is not supposed to be an Aqua first talk. All the tools that I'm going to talk about in my demo that you also see here, Tracy, Starboard, and Trivy are all open source. However, especially for Tracy and Trivy, you can use other tools from the cloud native space. So just take it as an example for the purpose of this demo. So what are those different tools? Just a quick overview. And I'm going to provide a demo on it. Trivy is basically used for scanning any resources for vulnerabilities and misconfigurations. So you can check, for example, whether or not you're using the latest tag of your container image or specific tag. Starboard is an operator. If you're familiar with the Kubernetes operator approach, it's basically an operator that's living inside of your Kubernetes cluster and automates processes within the cluster. So you have access to the information that it generates or, its outcome. And then Tracy is a runtime forensic tool that basically checks the system calls from on the kernel level. So you can implement it on your Kubernetes cluster and see what's going on a node level, which processes are requiring, are happening there. And in Trivy, again, to iterate, this is kind of the development lifecycle where we can implement those security tools. So when we develop our application, kind of more focused on engineers, that's when you can start using Trivy. We can use Trivy to test our applications before deploying them. And then we can use Starboard and Tracy to observe those applications. I'm going to show you how we can observe them through grafana. Through here. What I think I have a slide for that or not. So I'm going to use grafana. I'm going to use Prometheus. I'm going to use Loki and promtail for my demo and Helm as well alongside those tools. So demo time. First, I have a demo on how Trivy can be used to scan, for example, your container images first for vulnerabilities before you use them, or you can also check the base images that you use in your Docker file. So over here, just an overview of Trivy. You can scan container images, file systems. You can generate SBOMs, so basically inventory lists of your repositories for vulnerabilities, and just everything, all the dependencies that go into your software packages. Then you can scan remote repositories, GitHub repositories, and so on. And now we're going to go ahead and scan a container image. Now, I pre-recorded this demo earlier. There is some hiccups in the demo. So as you can see, here's just a list of vulnerabilities from that to be found within that container image. Now we can go ahead and we can filter for specific vulnerabilities as well. So for example, that can become really handy in your CI/CD pipeline when you want to filter for example, those high or critical vulnerabilities, and then fail the pipeline in case critical vulnerabilities are found within your deployment. Then we can scan GitHub repositories for vulnerabilities, and here I have an example repository, and within that example repository, I have a file that has different infrastructure as code configuration files. So that includes YAML manifests as part of my deployment, Terraform files, and Docker file. And Trevi can scan all of them, just checking them for vulnerabilities as well. Now, each vulnerability has a link attached to it, so you can find out additional information besides like the number of vulnerabilities. So what might matter to you is like, does one container image have more vulnerabilities versus another? Make the comparison versus if you want to dive into the exact vulnerabilities and see if they actually matter to your deployments. Now, I want to go to the next slide. This is the slide that I was looking for before. So these are the tools that are going to be part of my demo. Well, Trevi, I just showed you, but I basically set up a Kubernetes cluster with those tools to show you how you can integrate security-related tools into your normal observability stack that you would be using. So this is the main demo. I have here a Kubernetes cluster. It kind of, as I added new tools, it kept expanding. I used for the first time DigitalOcean as my Kubernetes cluster. So it was a bit of a tricky thing to set everything up. So this is my cluster in K9S. Here are the different namespaces. I have an application namespace with my app running. Then I have my monitoring namespace with all of my monitoring related tools, and my starboard system namespace where the starboard operator is running. Now, in the monitoring namespace, and I'm going to open that in a second. That's a tricky with pre-recorded videos, right? You have to wait for it. So over here, as you can see, I have the Kube Prometheus Stack Helm chart installed. And this is basically running Prometheus on every node within my cluster. The Prometheus exported, so I can access the metrics from those nodes. And then I have Grafana and Prometheus running, so I can access them. In this case, I'm doing port forwarding. I realized afterwards I did it actually the port forwarding on the pod. You might want to do it on the service instead, or in the production environment, set up an actual URL. So all of this is coming from this repository. The repository is on my GitHub account, so you can access it later and check out how I set everything up. And here is the prom configuration files, the value files that I used to set up the Prometheus stack chart. So first the Grafana configuration to have a data source Loki, and then I basically want to scrape all of my services for their endpoints, for their metrics endpoints. And then I have here my promtail configurations that has just links promtail to where Loki is running. So I have promtail running, and promtail is responsible for, I'm just going to pause here, for collecting logs within my cluster. So I have also promtail running in each of my nodes. And then it's forwarding to the different components of Loki. If you're curious about Loki and promtail, I've done with somebody else, with Urlichs who spoke earlier actually, a presentation at ObservabilityCon last year on Loki, where we provided a demo and showed how Loki works in more detail. So if you're curious about that, check out the demo. But yeah, so I have Loki running. So these are all of my observability related tools. You might have more. I'm sure we had more when I was working as SRE, but those are like the main ones. Now, going back to the namespaces. Here's my app namespace. My app kept crashing, but that's irrelevant for the demo for now. That's something to fix later on. So then I also have my starboard system namespace with my starboard related resources. And first of all, my starboard operator that's running inside of my cluster and monitoring different tools. And let's just see where it comes from. So this is the Aqua security GitHub account, and here are all of our open source tools. Now, you don't have to sign up to Aqua Enterprise or anything related to use those open source tools. Starboard is an operator that lives inside of your cluster, so you install it as Kubernetes resources, and then upon installation, it uses different scanners to do vulnerability scans. So for example, it uses Trivy to do vulnerability scans within your cluster of pods or replicas, depending on which is the higher level resource, and if it exists, and then it does configuration audit reports, CIS benchmark reports, and pen testing. We also added NSA reports just recently, which is not included here. Now you can access reports of your vulnerabilities, for example, as HTML or PDF format. We're going to use, in this case, Grafana and Prometheus to access our reports. And then we have also Lens integration, if you fancy that instead. So, and then we have the exporter to access the metrics from the Starboard operator as well. Now, going back to, well, I'm just going to port forward it here so I can show you the metrics that the Starboard exporter is collecting. It's basically all of the metrics that are coming from Starboard that are to provide the vulnerability reports inside of your cluster, for example, or the other scanning reports. So these are all the metrics that you can access. Now we're going to focus in this case on the vulnerability reports, on the metrics from the vulnerability reports, and visualize them in Grafana itself. So I actually earlier, when I first recorded the demo, I used the other metrics, and then realized I wasn't using the vulnerability metrics, so I had to switch and record the demo. Now, going back to the namespace, to my application namespace, we have here our vulnerability reports. As you can see, there are two different vulnerability reports. One is for the image tag 8.0.0, and then I updated it to the image running for that application 9.0.0, and they are both scanned through Trivy. And then you can access the CRDs for the vulnerability reports from within your cluster. And you can see here all of the different vulnerabilities that Starboard, or Trivy in that case, has found of that deployment. And as you can see, the new deployment has a lot lower vulnerabilities than the old one. Now, I hear the CIS benchmark reports, for example, and then I tried to access the KubeHunter reports, which I wasn't able to in that case, which I have to look into what the exact CRD was called. But yeah, then we can go again to our namespaces, and in the default namespace, I have Tracy running. Now, Tracy is again running on every, it's monitoring every single node. So you have here one pod running for every node, and it's collecting basically all of the events that are based on rules. So basically, Tracy has rules against which it's checking the kernels in your nodes. If there's suspicious activity, let's say, detected within those nodes. So, but you don't have to know anything related to the details of the Linux kernel or how eBPF works to track those events. Here, basically, just the logs that Tracy reports back that we can access later on through Loki. So in this case, for example, we can see that promtail has accessed the service account token within our cluster. And similarly, we can look for other, maybe more suspicious activity inside of our cluster. It might not come from existing applications that we know that we deployed. So for example, DigitalOcean uses Cilium as networking, I think. And here also it tells me basically which applications have accessed the service account token. Now, from here, we're going to move on to, well, you can find Tracy here also on the GitHub repository. You can run it either as a container image, just directly as a container image on your local machine, ideally if you have Linux running, and but you can also install it inside of your Kubernetes cluster ultimately. And then we want to go to Grafana and we want to access our dashboards. Now I've already set up 2 dashboards in Grafana that visualize all of my vulnerabilities in this case. So I have here 9 vulnerabilities of my latest deployments in total, and then there is a breakdown of vulnerabilities as well of the different, let me just stop here, and then I'm gonna forward it. Just, can I do that? Maybe not. Okay, maybe I shouldn't stop it anymore. Just to speed it up the demo a bit. But yeah, so I have 9 vulnerabilities in total, and then a breakdown of vulnerabilities within the application namespace. And then also I have here all of my metrics from my entire Kubernetes cluster. So I have, for example, in my entire cluster, I have 22 critical vulnerabilities. And then I have a pie chart breakdown of the different types of vulnerabilities that are within my entire Kubernetes cluster. Now, from there, we can go to, and I wish I could forward that, but it doesn't show me like the YouTube panel, the timeline. So as you can see, it's really easy to visualize the vulnerability reports in Grafana from your security tools, such as Starboard. Now you can also use other security tools, right? Now here, the dashboards for Tracy on the different, it's right now divided by the different types of rules it's checking. So how many logs are for each rule. Now, while I was recording, I realized that actually I have to rename some of the headers. So we have here in the top left, the total for TRC, for the TRC signature, and then we have the total for the TRC6 signature. So those are basically different rules that are checked on the host level within your cluster, on a node level. So, and then we have here our entire logs that have been collected from by Loki from Tracy over the past 5 minutes. No, it just started playing around with Tracy in your Kubernetes, in my Kubernetes cluster, but this is ultimately how you could visualize it and then filter through Prometheus and Grafana for specific types of logs and specific types of behavior that you want to detect within your Kubernetes cluster as well. Now, I think I'm going to stop it here since there's like still some minutes and I don't want to run over time and take from the next speaker. Now, you can find the demo for everything. You can find it on my GitHub account that's linked everywhere online for me. And then, yeah, you can find all of the Aqua security tools that I showed you are open source. So you can just play around with them. Let us know if you like them, how you like them. Yeah, so the main takeaway is just to iterate on everything that I showed you. And I know I packed quite a lot in this presentation. I think I have to get used to that. I can't edit the presentation afterwards, after recording. So ultimately, SRE goals are security goals. Security is for everyone. If I can get started with security in the cloud native ecosystem, so can you. You don't have to be an eBPF Linux kernel expert to get started with cloud native security. Security can be cloud native as well, so you don't have to use separate expensive security solutions to get started with cloud native security. They can all be Kubernetes native, so you can use your existing processes that you use for other Kubernetes related applications. And lastly, I just want to say Loki is awesome to access logs, and it's really easy to get started. Now, thank you for listening. You can ask me questions on my Twitter account. Also, I just want to mention I'm one of the co-organizers for DevOps Days Birmingham, which is from the 5th to the 6th of May, so next week. If you would like to attend and would like a free ticket, message me and I can send you a link to a free ticket. It's an in-person event, however, in Birmingham, UK. So, do we have a minute for questions? Or did I? No, I think I completely used all the time. I'm sorry.
You used it well, though. The comments were constantly how great your energy was. Clearly, this is a recording people are going to watch to process that information again and again. So feel free to share your slides. It's really good. And for those that haven't been to a DevOps Days event before, they are wildly inclusive and welcoming. And even there's childcare at this one.
There's childcare. Really cool. Let us know your dietary requirements. We really try to make it work for everybody who wants to come. So yeah, let us know how we can help you.
Impressive. Absolutely. Thank you so much for bringing the energy, the vibe, and recording your demos ahead so we could talk about them. And there was a lot of information, and it was all really good and really great energy. So thank you so much, Anaïs.
Thank you. Awesome.
And now it's time for the moment you've all been waiting for, because you want that swag that maybe has some themed items on it. The quiz. Who doesn't love a quiz? So please, may I call to the stage my partner, Tim and Tomas, who are going to be running the quiz. Good luck, y'all. You definitely want to play. The swag is really good and highly exclusive. Okay. Good luck, y'all.
Thank you, Jennifer. Yeah, welcome everyone to the quiz. So it's the quiz time. You will be able to win the prizes that we prepared here for you. So there is some swag that could be won. First thing first, the quiz is happening in Slido. We will put questions there. So what you need to do is either to scan the QR code that you can see here, or to go to slido.com and then enter the hashtag that we have here, WTF is SRE22. So those two ways to enter the quiz. I think we will do some intro here for just a few minutes, waiting for people to join. Hello team. You are running this track for half of a day already. How were the talks?
Yeah, it's going to be a long day, but I am really enjoying it. Some really good talks. Anaïs's talk was really good. Love the energy. Well, I'm seeing a load of people joining, and I'm loving this. But yeah, the talks on the DevSecOps track have been really good. And I know I'm going to spend another day or two going through the other talks of observability and reliability. I've been trying to keep up, but obviously I cannot follow them as much. But there are some really good talks. Have you been able to catch up with some, Tomasz?
Not too much, unfortunately, but yeah, I will be catching up with those and then following the other part. So yeah, it's like that, and can't wait to check some of those. Wanted to ask you, should we share with our listeners what the prizes are? What swag are we giving out to the winners?
Yeah, sure. So you'll have a limited edition WTF is SRE22 t-shirt, some stickers, and some socks. Socks with flames on top of it and dragons. And who doesn't love socks?
That's amazing. Yeah, I love socks the most from the swag options. Yeah.
So the person who will win can either contact us directly or Carla, our superstar event organizer and head of marketing at Container Solutions. This would not happen without Carla, basically. But before we go to that, we do need to go and do the quiz. There's a fair amount of people, so how about we start?
I would only mention two things to let everyone know what to expect. So just to reiterate for those who just joined, please scan the QR code or go directly to slido.com and enter the hashtag. We will have 20 questions, and bear in mind one thing, like some of those questions could be multiple answer questions. So it's not always only one answer to select. And we will have one winner at the end.
And as quiz masters, both myself and Tomasz have final say on the answers. Whether that's right or wrong, we're going to be judge and jury of the quiz. Cool. All right.
I think, we have a really nice bunch of people who already joined. So should we actually kick it off? What do you think? Let's go. Okay. So there will be 30 seconds for each question. The first question is, what does SRE stand for? And we've got 4 options: site reliability engineering, or system resilience engineering, or software robust expertise, or the 4th option, sipping rum enjoyably. Yeah.
I'm going to say that these questions come from our CRE team at Container Solutions. You might see a bit of alcohol team going on with every few questions now and again.
It could happen. Yeah. So most people thought this. Actually, everyone thought this answer is correct.
And
let's see. Indeed, it was the right answer.
So next question. Uptime SLA is 99.9%. How much time in a year can your servers be down before violating the agreement? 5 minutes, 15 seconds, 1 minute, 18 seconds, 8 hours, 45 minutes, 36 seconds, or 52 minutes, 35 seconds. I feel like this is where everybody is getting their calculator out going, okay, 99%, 365 days. What am I doing?
How to calculate it, yeah, what 3 nines really is, and so on. Yeah.
Oh, and we've got a spread. Majority on the 8 hours. So 99% availability means you can go down for 8 hours, 45 minutes, and 36 seconds.
Cool. The next question. What does CRE stand for? And we have first one, corn, rice, eggplant. Or is it customer ready earlier? Or is it customer reliability engineering? Or maybe customer resiliency engineering? 4 different options.
Some really good ones there.
Okay, and we should see the answers, how it's spread. So 2 options, quite popular, and let's see which was the correct one. Okay, so again,
I want to know the 1% who answered corn, rice, eggplant. Can you just tweet me or drop me a DM? I want to understand that. Cool, awesome. What does SLO stand for? Service level objectives, system level objective, slow life organization, system labels for orientation. I'll try and say that 10 times faster.
I like the slow life organization here.
As a Mediterranean, I think a slow life organization perfectly fit me. Chill by the beach with a beer in hand, maybe, or some rum.
Mm-hmm.
And the right answer is
service level objective. Indeed, yeah. Okay, the next one. What does being on call mean? First option, being in a Zoom call. Another one, being available in case of intervention is required. Or sitting in front of a computer 24/7, waiting to be paged. Or being the host or chair for a business virtual meeting. So being on call.
During the pandemic, we probably were all on call at a point in time.
Yeah.
Yeah.
Everyone thought this option, and it was the right answer.
Great. Question 6. What is an error budget? Amount of error that your service can accumulate over a certain period of time before your users start being unhappy, and we don't want unhappy users. Amount of errors you can see in your logs in a given time range, a budget that was calculated wrongly and now you can afford anything. What is a budget?
What is a budget? Yeah.
There you go. Answer your question with a question. And our spread, we've got a spread of people, mainly people who don't like unhappy customers, and that's the right.
That was right. Next one. What is the main difference between SLA and SLO? First option, SLO is contractually binding. SLA is there to help to stay within your SLO. Another one, SLA is contractually binding. SLO is an objective to help you to stay within your SLA. Or SLO and SLA are the same, or one has A and the other has O. And let's see the answers. Most people thought SLA is contractually binding.
We have the 1% who's gone a bit too classic.
Yeah.
And the right answer is there.
Good.
Question 8. What is 95th percentile? A value for which 95% of the observations are below it, a value for which 95% of the observations are above it, a person born in 1995. God, I'm feeling old. A drink that contains 95% of alcohol. Ooh.
95%.
I don't think anybody will be doing a lot of SRE after that.
Exactly.
Quite spread. Nobody's gone for the 95% alcohol. That's good.
Yeah.
And the right answer is a value for which 95% of the observations are below it.
Okay, question number 9. What are the 4 observability golden signals? First option, latency, violations, traffic, and saturation. Second option, latency errors, traffic, saturation. Third option, up, up, down, down, left, right, left, right. And the fourth option, MTDR, MTTD, MTTF, and MTTA.
I feel like one of them there is only for us old people who understand the cheat code.
Yeah. And yeah, we still have another question with most popular answer, and it was the right one.
Cool. Off to question 10. Observability can be shortened to O11Y. Why? Because an 11-year-old can handle it. Because there are 11 letters between O and Y. Because there are 11 principles of observability. Because there are 11 people in the team that coined that term. Some really good ones here.
Yeah, that is, I like the 11-year-old option. But
okay, fairly split spread over there. And I think, it's because there are 11 letters between O and Y. This is the same reason why Kubernetes is written K8S, actually. But before, I thought it was because at ease sounded like an 8. But no, it's because there are 8 letters between K and S. So we're halfway through the quiz. And I'm seeing a fair amount of people playing. So let's see our top 3 halfway through. Who is it?
Let's see.
Well, there you go.
Leaderboard.
Jason. Iru is in second, all with the right answers. Clint, Robert B, and Niv. Jason is fast. He's blasting through these. Come on, Iru, Clint. There's still time. There's still time to go.
Okay, next question. What is service level indicator, SLI in short? Is it a quantitative measure of some aspect of the level of service that is provided, or an indicator that tells you whether to deploy new features or work on reliability? Is it just another business buzzword, or an indicator that tells you when you need to upgrade your services version? And let's see what people answered.
Nobody's
Everyone said,
I love buzzwords.
Yeah. Okay, so let's see which is the correct answer as well. Indeed, it is quantitative measure. And no one said business buzzword, yeah.
Cool. Next question. How do SREs know what their system... Sorry, how do SREs know that their system is not operating as intended? They look at metrics and dashboards for 8 hours. They're just smart. I mean, we do have some very good SREs here at Container Solutions. Alerts are triggered when certain criteria are met, notifying them. They learn about it from Twitter. And I'm assuming if Jennifer Rigginson's there, she'd probably be tweeting fairly fast as well.
Learning from Twitter, yeah, it's sometimes like just like that.
And there you go. Pretty much everybody agrees alerts are triggered when certain criteria are met.
Good. Okay, next one. Is 100% availability the target for SRE? First option, are you implying that our services ever go down? Another one, no, because it requires enormous effort for negligible user happiness uptick. Third option, yes. And the last one, no, because we don't like round numbers and nines just look better. So let's see what people answered here. Some people said, yes, we should aim for 100%. And yeah, some people asked, are you implying it ever goes down?
I'd like to talk to these people.
Exactly. And the correct answer was this one.
Question 14. What are 5 nines in the context of SRE? 5 9-year-old kids operating your system better than you. That's always a possibility. 99.999% of something. Availability, successful, total requests, whatever. 45 open brackets, 5 multiplied by 9 close brackets, or tomato. I feel that our quiz masters weren't sure what to put on. And we've got full consensus that 5 nines is 99.999% of something.
Good. Next one. What are the 3 pillars of observability? And we have 4 different options: metrics, logging, tracing, visualizing.
This one is a bit of a toughie. If you're not on board.
Yeah, if you think about that, yeah, it could be a bit tricky, but yeah, the 3 pillars we are looking for here. Let's see. In a moment, we will see the results. So, quite a lot of people selected metrics, logging, and tracing. Let's see what were the correct answers. So the correct way to go was those 3 answers, indeed. Okay.
Question 16. What is MTTR used for? And we haven't said what MTTR means because it's in the answer. It is used to measure the average time between system breakdowns. It is used to measure the average time needed to repair a system after a breakdown. It is used to measure the time between 2 consecutive failures. It is used to measure the average time between Friday fun boards. I want it to be that one. Friday fun boards are always fun.
Yeah, exactly. So we need a metric for that. Yeah.
Alcohol. Oh, a bit of leeway there with measuring average time between system breakdowns, but the right answer is it is used to measure the average time needed to repair a system after a breakdown. Okay,
good. Next question. How are logs different from metrics? Select all that apply. First one, logs are aggregated, metrics are singular events. Second option, metrics are aggregated, logs are singular events. Third one, metrics are represented by a number, logs are in text format. Or maybe logs are represented by a number, metrics are in text format. It's, yeah, could be a bit tricky. Let's see. Most people selected those 2 options. Let's see the correct answers.
There you go.
Okay.
Getting close to the end. Which of the following tools are metric-centric tools? Prometheus, Greylog, Jaeger, Mojito. As I said, there's an alcoholic theme going on here. I think I don't know of any Mojito tool. But there's an alcoholic theme going on here. I might have a drink after this.
Absolutely. Yeah.
I hope everybody is pressing numbers fairly quickly. Jason, is he still on top? Getting closer to the end.
Yeah, we are almost there.
And a fair few said Prometheus, and that's the right answer. I like the 2% mojitos.
Exactly. That's good. Question 19. Which of the following tools are trace-centric tools? And we have Jaeger, Zipkin, Prometheus, OpenTelemetry. So 4 different tools are here, which are trace-centric. It could be more than one. Let's wait a moment more. Actually,
97 people have replied. 9,900.
Good.
How's system time?
Let's see. Okay, 3 options were most popular, and those 3 are indeed correct. And now, last question.
Okay, last question. Everybody ready? And let's see if Jason will be still on top after this. What is the purpose of the circuit breaker pattern? It detects failures and encapsulates the logic of preventing a failure from constantly occurring. It stops you from binge watching a series on Netflix. It ensures that on-prem servers do not go up in flames when overheated. And it stops microservices talking to each other when auto-scaling. I probably needed that yesterday. I binge-watched Russian Dawn, which is a really good series, actually.
Wow,
So
and you didn't have a circuit breaker there?
Final answer is, yeah, we've got a bit of a spread, but mainly people who know that it detects failures and encapsulates the logic of preventing a failure from constantly recurring. So that's it. Quiz is over.
Good.
Who has won? Tomasz, I'll drum roll you.
Yeah, that's time to see the leaderboard again. And the leaderboard changed its order. So, as we can see, the winner is Robert B. with all 20 questions answered correctly in a record time, just 4 minutes, 20 seconds.
Woohoo! Well done, Robert. Jason,
really
that one question.
Yeah, Jason.
And well done, Liv. Almost there. Robert, please get in touch with either myself, Tomasz, or, as we said, our superstar Carla through the Hopin application, and we'll to get all your details, and we will send you your package. Again, some awesome socks and one in a lifetime t-shirt. Thanks everybody for joining. Thanks Tomasz for co-hosting the quiz. I don't know if you want to say something else before we leave everybody on a short break.
Yeah, thank you everyone for playing this quiz with us here. Yeah, we encourage you again to do some networking here. So yeah, please reach out to people, talk to other participants, discuss the talk that you've seen. It's really, really worth trying to recreate the hallway track, basically.
We'd love to hear what you guys are thinking about the talks. Talk to each other, go to our booths, go to the expo, and stay within the COC of the conference. Cool. Thank you, gents and ladies. See you in a bit.
Thank you.